So welcome to College Algebra Summer 2020 Confer Zoom lecture course. Yay. I'm excited. I usually love to teach summer school. I hope that's going to be the same case this summer. It's a little different than I'm used to teaching, and I'm sure it's a lot different than what you're used to when taking a course. But I'm trying to make this as most like a normal class as if I was in in the classroom with you guys. Very unusual to be in my bedroom teaching. I've never done that before until this morning. So we're part of this is going to be a learning experience for both of us. I did get to finish off last semester with teaching through Confer Zoom, and I continue to teach my courses during the time that our classes met. And I know that my students really appreciated that, and hopefully you guys appreciate that too with coming together at a certain time. But I want to, before we go on any further, I want to introduce you to Zachary. And Zachary right now has 1 hour a week, and he set aside to tutor students just for my course, College Algebra, during that time. And so let me pause the recording and let him introduce yourself. So just in case he's camera shy. Okay, so we're just kind of talking about the course real quick. And question? Okay. And what to kind of expect. So we'll be meeting here Monday through Thursday, 1 to about 3:50. And I will be lecturing probably most of the time. Unfortunately, this class, there's like 52 sections we need to get through in 6 weeks. And so if you do the math, and we have lots of Thursdays that we're going to be using for testing, we're going to be trying to get through about 10 sections a week. So that's kind of crazy, guys. College Algebra, the first part of the course is really, a lot of it is review of intermediate algebra. It might go a little more in depth than questions that you had if you had taken intermediate algebra or algebra 2. I don't know what else it's called nowadays in high school. I know they're doing, I don't remember. Anyways, the other part of the course is a lot of graphing. So we'll be getting into graphing different types of equations, ways to graph things that are not quadratic. So pretty much all you've been able to graph maybe are parabolas, circles, lines, but we're going to get into more depth of graphing. And also solving different types of equations. Anyways, this course is really, really helpful if you're planning on going on into calculus. Unfortunately, you won't see a lot of, you're getting all the tools you need to be very successful in calculus. Okay. There is a chat feature on here, and unfortunately, a lot of times I don't notice the chat's going on because I'm so caught up in what I'm saying or writing. So if you ever have a question, probably the best thing to do is just kind of unmute your mic and just holler it out there. Let me go and show you your course homepage, which you've been, because you've been able to get here. Let me share my screen with you real quick. Okay, so this is how you got into class, and this is the College Algebra course. If you scroll down below, this is where you're going to get links to tutoring. So they have tutoring sessions, again, open from 8 a.m. to 2 p.m., 3 p.m. to 7 p.m. Those are drop-in basis. There's tutors in there waiting to help you. So this is how you would get in there. And then for Math 20, Zachary, I guess, is only there available from 10 to 11 a.m. I guess they're looking for somebody right now to be a tutor from 11 to 12. If you're successful in my course and you would like to be a tutor in the future, I'm always looking for my A students that look like they understand the material and can explain it to others really well. And that's a great job to have going through school, is being a tutor. Kind of the best times way to learn something is to be able to explain it to somebody. Here is also where you're going to find where to do most of your homework. So most of your homework is going to be in quizzes, and probably your tests are going to be on my math lab. And so right here, this is the first semester I've hooked it up where you can link into the program without going to a different website. And so you would just click on this, and it's going to bring you there. My math lab does cost money. And so I think it is $69 if you want an 18-week code, and I believe it's a little over $100 if you want a 24-week code. It's not looking there. For my math lab, you can access the program for 14 days. Without paying it. So if for some reason you're not sure that this is a course for you, maybe it's going too fast, you want to just kind of try it out and be able to do your homework and get started and everything, you can use the program, do all those things for 14 days without paying for the program. I believe if I open it now, because I'm not in student view, it's not going to show you, you know, the steps on I agree to the conditions and stuff. It doesn't. So once you get signed in, it will probably bring you to this page right here right away. Yours looks a little different because you're not the instructor, but it's pretty much the same. And you're going to just click on assignments. And so you'll notice that there's assignments already in here. So I've put in here what I thought I would get through in 1 week. And so again, we're going to be, especially at the beginning of the course, I want to go faster because this is more of a review to you than new material. So we are going to be flying, literally flying through this course. So once you get in here, you can click on your assignment, click on the problem. And one of the reasons I love the internet and the programs is because you have all these help features right here to help you if you get stuck. I don't want to go to this problem, but here is question help. And here you see it will bring you to the textbook. You can use a calculator or print. So for some reason you don't like to do your homework with the computer open where you're inputting the questions or answers right away, if you go to print on any of the questions, it will tell you, you know, do you want to just print this question or do you want to print the whole assignment? And so you can print the whole assignment off, work on it, and then come back to the computer and put your answers. The nice thing about inputting your answers right away is that you know if you're doing it right or wrong, and you're not hammering in some concept that you think that you're doing right and then find out later that, no, there was something off. Let me do that. Let me scroll down real quick. Okay, so here's an equation solved for R. So Q is equal to C all over 1 minus R. And so we wanted to get R by itself. And so again, I can go to question help. So notice there's a little more features here. So help me solve this or view an example. So these are great features that will help you. Help me solve this will help you solve this exact problem. It will walk you through step by step. The thing is, when you do that feature, it's going to bring up a new problem when you're done getting help with it. View an example is going to view an example that's similar to what you're looking at, but a little differently. And that will bring you back to the same question when you come back to it. You have a certain number of times to get a question right. If it's short answer, you have 3 attempts. So if you put in an answer and then you would check it, it's going to tell you if it's wrong or right. It gives you positive feedback if it's right. If it's wrong, sometimes looking at what it says is really helpful because it might tell you what you did wrong, or it might tell you your answer is right, but it's in the wrong form. So you might have put it in a decimal form and you didn't read the directions that said put answers as a fraction. Or you might not have rounded the right way. So reading that could actually help you, and so that you're not banging your head against the wall trying to figure out what you did wrong. While you're doing your homework, you're writing up your homework just like you were writing it up out of a book. You're keeping track, showing your solution, the solutions on how you got your answers. You're doing it in a clear, organized manner. That's one of the cool things about mathematics, and an important feature that you get out of mathematics in itself. Things are logical. Things need to be in order. If for some reason you go through the problem and you get the answer wrong 3 times, in this case, it will tell you above that the question is marked wrong. But you could get your homework up to 100% if it's turned in on time, because you can always do a similar example. So if you do a similar example, it will let you, and you get it correct, then it will mark this as correct. You don't have to worry about saving things. It will be saved when you come back in. You do want to know that your questions could be a little bit different than somebody else's questions. So if you're printing it off, you'll come back to the website with the same questions, but you don't want to be sharing that with somebody else because their questions are probably different. Different letters, different numbers, but same concept. Okay, so whatever we cover Monday, Tuesday in one class is always due Thursday's class by class time. So what I cover on my math lab, if you go back to Canvas, to the home page, I'm going to start posting what I cover each day. So, sorry. So weekly class information. So right now you already have an assignment to do today. You're going to read the syllabus and you're going to submit the syllabus as one PDF. The directions are in here, but this is where I just want to show you that I'll be listing what sections we cover each day. So my plan was to get through chapter 1 and chapter 2 this week, but I don't know if that's going to be the case. So I will post which sections are covered. Whatever I cover Monday, Tuesday, again, is due on Thursdays. My math lab before class by 1 p.m. You can get in and do homework late, but it's going to knock off 20% of what you did not complete before the due date. So if you didn't get in and do any of the section before the due date, then you can get up to an 80%, which is still a B, which is better than a 0. If you've done most of the homework and maybe didn't get through one question because you needed help, then when you go back to do that one question, it's only knocking off 20% off that one question. So you're going to get definitely higher than an 80%. Homework in general is worth 20% of your grades. That's something that you want to definitely be in and keeping up with. That's also what's going to help you with your exams. Your exams are probably going to be through my math lab, so you'll have similar questions. You'll know how it runs and how they word things. What else do I need to tell you? You're writing up your homework, like I said, just like you were writing it up out of a book. You want to keep that organized. If for some reason you go back in there and you did section 1.1 and it says you didn't do it and you're freaking out, well, you have all your work that you did on chapter 1.1 that you can show me and I can go in there and give you credit. That's never been the case before, but you never know, something could happen. If for some reason you believe you got an answer right on my math lab, but it says it's wrong, then you can always email me. Email me the section number, the problem number, and I can go in and I can look at it. And if I see that it's right, then I can give you credit. Usually it's something the student did wrong, but sometimes it might be, you know, instead of putting a capital S, you put a lowercase s. And it marked you wrong. I can definitely see that you knew what you were doing and give you credit. So that's pretty much the course, kind of in a nutshell. Reading through the syllabus, you'll kind of learn a little more about it. So that first assignment is due tonight by midnight, is to read through the syllabus, go through, initial each item on the syllabus. You're initially saying that you understand what is being said. And if you don't understand what is being said, or if you have any questions, star it, and then on a separate piece of paper, you're going to write out what you don't understand or what you need clarified. And since you're uploading that by midnight tonight, hopefully by tomorrow's class, I will read through any questions you guys have over the syllabus, and I can clarify that before we start lecturing. Okay. So I'm going to pause the video so that if you guys have any questions, you can ask, and then I can bring anything up that I need to mention to those who are not here. Okay, so we are going to jump into material right away. And like I said, I'm going to try to get through chapter 1 and 2 this week, and I'm trying to get through material that we've covered before in the past. That should be a review faster than the stuff that you've never seen before. And so you should see my screen, and oops. We're going to be looking at solving equations. So chapter 1 is solving different types of equations and solving inequalities. And 1.1 in our textbook is talking about linear equations. Okay, so linear equations. Okay, so when we're looking at linear equations and we're solving, there's different types of things that could happen. We can get solutions that are conditional. So maybe there's just one number that would work, that if you plugged it back in there, you would get a true statement. You could get something where you have an identity, or there's an infinite number of solutions. Or we can get something which is inconsistent, where that means there's no solutions. Okay, so when we're looking at linear equations, basically you have an equation, right? And so our equation is kind of like a scale, right? Think of it as one of those, I don't know if you guys have seen them before, kind of out of date, but those scales that they're even. And if you put something more on this side, it's gonna outweigh it, right? And so we wanna keep them equivalent. So if you do something to one side of the equation, you gotta do it to the other side. And so solving equations, we kind of go through a process. And so the first thing that you want to do when you're solving equations is really identify what type of equation it is, because that depends on how you're going to solve it. And right now we're working with linear equations. Usually the first thing that I would do, depending probably, is to simplify each side of the equation as much as possible. So simplify each side of your equation. So sometimes you might need to use your distributive property. Combining like terms. So once you've gotten both sides of that equation simplified as far as possible, that's when you're trying to get, for linear equations, the goal is to get all the terms with a variable you want to one side of the equation and everything else to the other side of the equation. So you're going to get all terms with a variable you're trying to solve. To solve for on one side of the equation. And all the other terms to the other side of the equation. So whatever you do to one side of the equation, you got to do it to the other. So if you're multiplying to one side, you got to multiply to the other. If you're adding to one side, you got to add to the other. And then once you've done that, solve for your variable. Okay, so for example, if I have the following, let's just start kind of easy. 6 plus 3x is equal to 9x plus 6. And it's important that you understand terminology. So when I said simplify each side of the expression or equation, right, I'm looking at 6 plus 3x and I'm looking at 9x plus 6. Get all the terms with the variables you're trying to solve, or combining like terms actually is what the next thing I want to talk about. So notice 6 plus 3x, those are not considered to be like terms, right? In order to be a like term, what has to be the case? So they have to have, each term has to have the same variable, which is the letter, and they also have to be raised to the exact same power. And so this term 6 does not have an x in it, and so it's not a like term to this 3x. Terms, notice, are broken up between pluses and minuses. So on the left-hand side of this equation, there's 2 terms. On the right-hand side of this equation, there's 2 terms. We cannot add terms across the equal sign. So I could not add this 3x plus 9x across the equal sign. But I do, and so actually, the next step was saying simplify each side. This is already simplified as far as possible on each side. And so I want to get all the terms with x to one side of the equation and all the terms without x on the other side of the equation. It really doesn't matter which side you decide to get the variables, terms with the variables to, and which sides you get the constant to. Our constant is the number or term without the variable. So 6 is a constant. 3x and 9x are terms with variables. Okay, so I want to get x to one side and I want to get terms without x on the other side. So if I get rid of the 3x on this side of the equation, I can undo it, right, by subtracting 3x. But if I subtract 3x on this side of the equation, I have to subtract 3x on the other side of the equation. And so bringing down what we have left on the left, I just have my 6 here. Well, 3x minus 3x cancels, and that's the whole point, was us subtracting 3x. We have 9x minus 3x is 6x plus 6. We want to get the constant to the other side. So if we subtract 6 on both sides, well, 6 minus 6, that is 0, is equal to 6x. So some of this you can do, I know you can do without showing that step, but for right now, I'm going to show the steps for a little bit. And so we want to get x by itself. We're not done. I want to get x equals, not 6 times x equals. Well, so this is 6 times x. I can undo multiplication, right, by dividing both sides by 6. Or think of it as multiplying by the reciprocal of the coefficient in front, or multiplying by 1/6 if you want. So 0 divided by 6 is 0, is equal to x. Okay, so x is equal to 0. So you can always check your solution by going back and plugging this in. This is a conditional solution. There's only one solution that would work, and we went back in and plugged it in for x. And if we did that, we'd have 6 plus 3 times 0, which is 6, and we'd have 9 times 0, which is 0 plus 6. So 6 is equal to 6, and we're good. So let's say you had 2x minus, and then you have a parentheses, 3x plus 3, and your parentheses is equal to 2x minus 18. So looking at this, I noticed that my left-hand side of my equal sign can be simplified. I have this minus outside of the parentheses, so we're basically using the distributive property. We're thinking that there's a -1 outside of the parentheses, so we have to distribute it to each term inside of that parentheses. Okay. So it's important that you carry everything down that you didn't do. So we're going to bring down this 2x, but we're distributing -1 times the quantity 3x plus 3. So -1 times 3x is -3x. -1 times 3, so minus 3, is equal to 2x minus 18. So I still can simplify the left-hand side of my equal sign. I notice I have like terms. I have a 2x minus a 3x. So 2 minus 3 is -1. So this would be -1x. You don't usually write the 1 in front of it though. Minus 3 equals 2x minus 18. So we want to get x by itself, and we want to get the terms without x to the one side. So if I subtract 2x on both sides to get the terms with x on the left-hand side of the equal sign, and at the same time, let's add 3 to both sides so we can get the constant to the right-hand side of the equal sign. So I have a -1x minus 2x is -3x. My -3 plus 3 canceled equals 2x minus 2x cancels, and -18 plus 3 is -15. So -3x right now equals -15. Get x by itself, we need to divide, because there's a multiplication in between. And so we get x is equal to 5. So again, we could take this, we could plug it back in wherever we saw an x in our original equation, simplify using order of operations, and show that you got a true statement. I'm gonna do that though. Okay, so sometimes we have fractions, and if we're dealing with equations and there's fractions, we can get rid of those fractions by multiplying by your least common denominator. So let's say you had the x plus 4 in the numerator, and that whole quantity was divided by 2. And then you had plus x plus 1 in the numerator, and that is all over 3, is equal to 10. So again, we can only clear the fractions because this is an equal sign. If this was an expression, there was no equal sign, then we couldn't do that. Notice there's no variable that's in the denominator though. If there was a variable in the denominator, we'd have to be careful with our solution. We can never let the denominator equal 0. So first up, if there's a fraction, you don't have to do this, but again, it's the easiest way is to get rid of those fractions. So let's clear the fractions by multiplying by your LCD. And so if you look at the least common denominator of 2 and 3, the smallest number those both divide into, that would be 6. So 2 goes into 6 evenly and 3 goes into 6 evenly. Okay, so we're using the rule that if we can manipulate this to figure out what our variable is by doing the same thing to each side of the equal sign. So if I multiply the left-hand side by 6, so it's the whole quantity though, x plus 4 over 2 plus x plus 1 over 3 is equal to, so 6 times the other side of the equation, 10. So basically we chose a number that our denominator divides evenly into so that our fraction will go away. And so when we distributed the 6 to each term or each piece on the left-hand side, notice that 2 goes into the 6 evenly. Let me just write it out where I distribute the 6 to each term. And that 3 is going to go into the 6 evenly. On the right-hand side, I have 6 times 10, which is 60. Okay, so notice our denominator again, 2 goes into the 6 3 times. And this 3 for the second grouping goes into this 6 2 times. So we technically have this 3 outside that has to be distributed now to my numerator x plus 4 for this first grouping. And so if I distribute it, we get 3 times x is 3x, plus 3 times 4, which is 12. Now let's distribute this 2 into the second grouping. So 2 times x and 2 times 1. So we get 2 times x is plus 2x, plus 2 times 1 is 2 equals our 60. Okay, so looking at this, I can simplify the left-hand side of the equation because we have like terms. And so we have like terms to 3x would be any other term on that side that has an x, which is 2x. So we have a 3x plus a 2x, that gives you a 5x. And then we have our constants, we have a positive 12 plus 2. So 12 plus 2, so that's a plus 14, equals 60. So we've cleared our fractions, we've simplified each side of our equation down as far as possible. So now we want to get the term with a variable by itself, and we want to get the constants to the other side. And so we don't want the 14 added to that 5x, and so we're going to subtract 14 to both sides of the equal sign. So we're left with 5x on the left-hand side is equal to, well, 60 minus 14 is 46. So we have 5x is equal to 46, and now we need to get x by itself, and it's 5 times x, so if we divide both sides by 5, we get x is equal to 46/5. Okay, so this is where you want to be careful on how your solution needs to be written. So if my MATLAB did not specify how it's written, it should take it like this. They always want it in the simplified fraction, if it's fraction reduced down as far as possible, but 46 and 5 don't have anything in common. If they say write it as a whole number or a mixed number, then you're going to have to rewrite this. So 5 goes into 46 9 times evenly, not evenly, and that gives us 45, so we have a remainder of 1. So this is the same thing as 9 1/5. But if they don't say, then we could probably write it in any of 3 of these forms, which are the same. You could write it as a decimal, 9.2. Okay, so let's try something. I'm going to do a try it. So you guys are going to try it and see if you can do it. So let's say you had 1/4 plus 6 over x is equal to 5 over 8. So I'm going to pause the recording and then I'm going to let you guys try it for a moment and then come back and we can talk about it. Okay, so you guys had a chance to solve this, and you probably, well, you should have gotten x is 16. But how you would have gotten that is looking at this, we have an equation. I had noticed that I have fractions. And so first thing we want to do is clear the fractions, and we want to look at the least common denominator of all those fractions within the equation. And so your least common denominator of 4, 8, and x, well, if you just look at the numbers 4 and 8, the smallest thing they both divide into is 8. But we also need an x because of the 6 over x. So the LCD for those denominators is 8x. And so technically, and we can kind of save some time, is we're going to be multiplying 8x on both sides of the equation. So instead of thinking of it as distributing, we could rewrite it as 8x times each term. So 8x times this 1/4 when I distribute on the left, plus I have 8x times this 6 over x is equal to our 8x times the 5/8. Again, we chose something that our denominator would divide evenly into, so our fractions would go away. So 4 goes into 8x, we're left with, well, 4 goes into 8 twice, so you're left with a 2x. Plus, well, x goes into 8x, the x's cancel, and you're left with 8 times 6, which is 48, is equal to, and the 8 cancels with the 8 here, and so you're left with x times 5, which is 5x. Okay, so once we've went through and cleared our fractions, I would look to see if I had any like terms. Can I simplify each side of my equation, which I can't. And so now get terms with the variables to one side. So I would subtract 2x on both sides because the right-hand side just had an x on it. And so we get 48 is equal to, well, 5x minus 2x is 3x. And so we want x equals, so undo multiplication, you would divide. And so we get 3 goes into 48 16 times. Well, 3 goes into 4 once, right? With a little remainder of 1. And 3 goes into 18 6 times. Okay, so hopefully that clarifies, if you weren't able to get it, how to get it. Okay, so sometimes these equations that we're working with didn't start out to look like a linear equation, because this 1/4 plus 6 over x equals 5/8 is actually not a linear equation. but as we were manipulating it, it became a linear equation. So notice this example, next example. When we start out with it, it actually looks like a quadratic equation. So that means that the exponent is 2. So if you have, let's say, x, and this is all times the quantity of 2x minus 5, this is equal to, parentheses, 2x plus 2, all times the quantity x minus 3. Okay, so again, looking at it, it's an equation. There's no fractions, or okay, we don't have to clear fractions, but we want to simplify each side of the equal sign down first. And so I noticed that this x, there's no sign in between this x and the parentheses. So that means it's multiplication, and I need to distribute that to each term inside the parentheses. So remember or recall power. So sometimes I'll be doing this. So remember, there's a rule. If you have the same base and you multiply, the rule was that you add your exponents. And so we're kind of using that rule here when we distribute the x. And so we have 2x times x. So this is 2, add our exponents. This is an x squared. We have x times negative 5. So this gives me minus 5x. Is equal to, so I need to distribute here. So I have 2x, I have to distribute it to each term inside the second parentheses. 2x times x is 2x squared. 2x times negative 3 gives us negative 6x. And then we need to distribute the next term in the first parentheses to each term in the second parentheses. So 2 times x gives us plus 2x. And 2 times negative 3 gives us minus 6. So we can simplify on the right-hand side of the equation, not the left. So even though both terms have an x in it, they're not like terms because one is squared and one is not. And so we can't combine those. We're just going to rewrite it as 2x squared minus 5x is equal to, but my right-hand side of the equation, I have two terms that are like terms. This negative 6x plus the 2x. And so we have 2x squared, negative 6x plus 2x. Opposite sign subtract, carry the sign of the larger number. So 6 minus 2 is 4. The sign is in front of the 6, which is larger. So this is negative 4x minus 6. Okay, so at the beginning of class, I said it kind of really determines what equation you have, kind of determines how you approach solving this. So first thing I see is it has the x squared, which tells me it's quadratic. If it's quadratic, a lot of times we approach that by getting everything to one side of the equation and setting it equal to 0. But then I noticed that if we subtract 2x squared on both sides, notice that cancels, and we no longer have a x squared term. And so this actually ends up being a linear equation. And so we have negative 5x on the left is equal to negative 4x minus 6. So we want to get all the terms with x on one side, all the terms without x on the other side. So if we add 4x to both sides, well, negative 5x plus 4x, opposite sign subtract, 5 minus 4 is 1. Larger number had the negative in front, so this is negative 1x equals negative 6. So divide both sides by negative 1. We get x is equal to positive 6. Okay, so the next type of equation, when we look at it, is a rational equation, which means that you have fractions where you have variables in the denominator. It's actually that one triad was a rational equation to start with. So this one you have x, and then in the denominator you have an x minus 6. And then you have a plus 1 outside, but the fraction is equal to 6 over x minus 6. Okay, one thing I should have mentioned back up here is that when you did that try it, we had a variable in the denominator. And so if our solution had been x was equal to 0, then this would have had no solution at all. And so sometimes if you are starting with an equation where you have a variable in the denominator, it's helpful if you tell yourself what x cannot be, so that if that is what your solution came out to be, you know to exclude it. So in this case, x couldn't be 0. But if we look back at our new problem, we know that looking at this, x cannot be, well, if you can't see it, you can see that x minus 6 cannot equal 0. So we could always set up the equation and solve for x there. So if we get our solution is 6 at the end of solving this, then we would know that there's no solution if that was the only answer we got. Okay, so looking at this, it's a rational equation. So we want to clear the fraction, and so we want to multiply by our LCD. Well, if you look at the fractions, they have the same common denominator. They have the same denominator, x minus 6. So your LCD is x minus 6. You need to be careful here. You have to multiply x minus 6 to both groupings on the left-hand side. So you're multiplying that x minus 6 times the fraction, x over x minus 6. But do not forget to also multiply it to that 1. So we have that x minus 6. All times the 1 is equal to x minus 6. On the right-hand side, all times the 6 over x minus 6. So we have the same factor of x minus 6 in the numerator and the denominator. And because we did that, we can cancel it. So for that first grouping, when that cancels, all you're left with is an x plus, nothing cancels for the second grouping because there's nothing in the denominator here other than 1. And so 1 times that parentheses x minus 6 is x minus 6 is equal to, and then on the right-hand side, the x minus 6 is canceled and you're just left with 6. So combine like terms on the left, we have x plus x, which is 2x, minus 6 equals 6. Get the variable, isolate the term with a variable, so we could add 6 to both sides. So we get 2x is equal to 6 plus 6, which is 12. Divide both sides by 2. So x is equal to 6. Okay, but that makes the denominator go to 0. And so this cannot be a solution. And so this equation actually doesn't have a solution. Okay, so let's look at one more. Let's see if you guys can do it. So let's try it again. So this time you have 5, and that's all over the quantity x minus 2. And then this is equal to -3, and that's all over the quantity x plus 2. And then we have plus 28 all over the quantity x minus 2. That quantity times the quantity x plus 2. So while you guys try that, I'm going to just pause the recording. Okay, so we got a couple different answers, 11/2 and 3, and so we're just going to go through this real quick again and solve for it. So looking at this, you should notice you have a variable in the denominator, so there's certain numbers that x cannot be. And so we cannot have x minus 2 equal to 0, and that would be when x equals 2. That would set that to 0. So x can't be positive 2, and x plus 2 is 0 when x is negative 2. So there's two values x cannot be, either 2 or -2, and if that was part of our solution, then we would say it actually was not part of our solution, so not an answer. You needed to look at the LCD, so we can go through and multiply each grouping or piece of the side of the equation by the LCD. Well, x minus 2 is a different factor than the quantity x plus 2. And so our LCD is both the x minus 2 and the x plus 2. So you're going to want to multiply that to each piece. And so if I multiply the left-hand side, x minus 2, all times x plus 2, all times this grouping, 5 all over x minus 2 is equal to, and so then if we take this x minus 2, x plus 2, multiply it to the -3 all over x plus 2. And then we have plus, so multiplying the x minus 2, x plus 2, all times the 28 all over x minus 2, x plus 2. So notice things cancel out. So x minus 2's cancel, and you're left with 5 times that quantity x plus 2. So let's just distribute right now and bring it down. So we have a 5 times an x is 5x, plus 5 times 2, which is 10, is equal to, so over here, x plus 2's cancel, and we're left with -3 times this quantity, x minus 2. So let's distribute it. So we have -3 times x is -3x. And we have -3 times -2. Negative times negative is positive, so +6. And then over here, this x minus 2, x plus 2, they canceled that. And so you're just left with +28. So looking at this, after canceling the fractions, we're left with a linear equation. I notice the right-hand side could be simplified by combining like terms. So let's just rewrite the left-hand side, 5x plus 10. This is equal to, well, -3x, that's the only term, so -3x. But 6 plus 28, that's plus 34. So I want variables to one side, if I add 3x to both sides, and constants on the other. So if I subtract 10 on both sides. So we get 5x plus 3x is 8x is equal to 34 minus 10 is 24. Divide both sides by 8 to get x by itself. Well, 24 divided by 8 is 3. Make sure that was not one of the numbers that set the denominator equal to 0, and it wasn't, so we're good. So hopefully you saw what you did wrong, the one that got 11 halves. So this looks like a good time to take a break because my computer's starting to act up with my writing. So if I close out of this and come back in, it would probably work good. So it says it's about 2:11 right now. This is a long class. So let's go take a 15-minute break, go get something, snack or some water or something to drink, walk around, move, get your blood flowing, and let's meet back here at 2:25. Sound good? So I'm just gonna, okay, good. I'm gonna mute my thing and just turn off my video until I come back. I'll see you guys in 15 minutes. Okay, so now we're going to look at where we have an equation where you have multiple variables in an equation and you're trying to solve the equation for one of those variables. And so pretty much we do the same process that we were just doing, except that some of the terms have a variable in it and we don't want to solve for it. So for instance, if you had 1 over r is equal to 1 over r sub 1, plus 1 over r sub 2. And let's say it asked us to solve for r. Okay, so we want to get r by itself. So this is an equation that has terms in our denominator, and so we want to clear our denominator, and we can do that by multiplying by the LCD. Okay, so the LCD for here is equal to r sub 1, and r sub 2. Because that little subscript is representing that this variable could represent a different number than the others. And so we can clear our fractions by multiplying each side of the equation by this r sub 1, r sub 2. So if we do that times this 1 over r is equal to, and so on the other side, it's like we're distributing this r sub 1, r sub 2 to both of those groupings. 1 over r sub 1 plus, I'm distributing it to the term r sub 1, r sub 2 to 1 over r sub 2. So the fractions go away. So r divides into r, and you're just left with r sub 1, r sub 2. This is equal to r sub 1's cancel for this first grouping, and you're left with r sub 2. Plus, and then r sub 2 cancels, and you're left with r sub 1. Okay, so we want to get all the terms that just have the r to one side of the equation and all the terms that don't have just the r in there to the other side of the equation. So actually notice that that's already done for us. All the terms that have just the r in it are to one side of the equation and the other side has r sub 1, r sub 2. If that hadn't been the case, that we would have manipulated it to get it that way. Okay, so notice there's more than one term that has just that capital R. we cannot combine these two terms because they're not the same. One has R sub 1, one has R sub 2. They don't have the identical variables in there. So the trick is when there's more than one term with that variable you're trying to get by itself, and you can't combine them like that, the trick is to factor that out of the terms. So on the left, we're still left with R sub 1, R sub 2. We didn't do anything to that. Is equal to, but on the right-hand side, we're going to factor out that capital R from both of those terms. And so left in the parentheses, we're left with R sub 2 plus R sub 1. And so now notice that capital R is just in that equation once. And so we can get that capital R by itself by dividing both sides of the equation by that parentheses. And so if we divide both sides by the parentheses, R sub 2 plus R sub 1, we'll be just left with what we wanted, which was capital R. So capital R is equal to R sub 1, R sub 2, all divided by R sub 2 plus R sub 1. If I had that capital R on the right-hand side of the equation too, then I did something wrong. The variable that you're trying to solve for should be all by itself on one side of the equation. So let's look at one more. So let's say you had A is equal to P, all times the quantity 1 plus RT. Okay, so I don't know if you noticed, but that equation above that we were working with was an equation for electricity, and the equation we're looking at now is an equation for principal and an amount after a certain time period. Simple interest problem. This wants us to solve for R. So we're trying to get this R all by itself and everything else to the other side. So there are a couple of different ways that we could approach this. I notice I can distribute my capital P to each term in there, or I notice because it's multiplication, strictly multiplication here, I could divide both sides by that capital P. Just because I would prefer this as one fraction and not multiple fractions, it's not wrong. Let's first distribute that capital P. And so on the left, we have capital A is equal to, well, P times 1 is P plus P times RT, so PRT. So we're trying to get the term with R all by itself, and so we don't want the P with that PRT, and that's addition in between, and so we could get rid of that P by subtracting P on both sides of the equation. A and P are not like terms, so we're just going to write it as the difference. So we have A minus P is equal to PRT. So now we have the term with R in it all by itself on one side of the equation, all the terms without R on it on the other side of the equation. So to get R by itself now, this is strictly multiplication in between all three of those variables. We could divide both sides by PT. So doing that, we get R is equal to A minus P, all divided by PT. Okay, so you got to be careful with reducing fractions. This is a difference between the P and the A. We can't just cancel these P's in the numerator and denominator. If I split it up as two separate fractions, then I could cancel it in the one, but not the other. Okay, so this was solving linear equations, or linear equations that could be manipulated, or when you're starting to work on them, turn into linear equations. Let me bring up a new page. And we're going to look at quadratic equations. So solving quadratic equations. Okay, so quadratic equations are a little different, and the way that you approach quadratic equations are different than linear equations. Quadratic equations have multiple ways that you can approach them and solve them, and some ways are easier than others. If it's factorable, that's usually the fastest, easiest way to go about it, but unfortunately, quadratic equations aren't always factorable. And so you could do things like the completing the square method, which you need to know how to do. But it's not always the easiest method to do. Or you can use your quadratic formula. Sorry, my cord just unplugged, so I was trying to fix that. Okay, so quadratic equations are in the form of ax squared plus bx plus c is equal to 0. We have to put a stipulation, because this is a quadratic equation, that that coefficient, that number that is in front of your x squared, cannot equal 0. If that was 0, then you only have the equation bx plus c equals 0. And that would be a linear equation because of the value, or the exponent on x is 1. Here we're letting a, b, and c are real numbers. So let's say that we wanted to find the following, or solve for the following. Let me just pull up some questions.
Excuse me, Professor.
Mm-hmm.
Could you please remind me how to know what the variable cannot be equal to? Like in this case, you already said a cannot be equal to 0. I don't remember how.
Okay, the only reason why a can't be 0 is because if the number in front of the x squared had been 0, that would have given us, because 0 times anything is 0, right? And so that would have given us the equation instead, bx plus c equals 0, if a equals 0, if that had been the case. If a is equal to 0, then this is no longer considered a quadratic equation. This is a linear equation. And so the only reason I put that stipulation there was because in order for it to be a quadratic equation, that's the only case that a couldn't be 0. If a was any other number, then it would be a quadratic equation. And so to be quadratic, that was the only stipulation. If we're solving equations though, and we have variables in the denominator or things underneath the radical, which we'll talk about later, there's values that we have to set that x cannot be, because it's not technically in the domain of our solution set. And so quadratic equations, so they're going to be able to be written in this form where your highest exponent and your exponents for polynomials, and we'll talk about this later too, are always whole numbers. They're not rational numbers, which means they're not fractions or square roots on those variables. Don't have to worry too much about what I'm kind of explaining right now. But let's look at a couple examples. Let's say you had x squared plus 4x equals 0. So I know this is quadratic because my highest power of x is 2. So if it's a quadratic equation, usually you want to set everything, you want to get it equal to 0. So set equation equal to 0. And so you might have to manipulate it where you're getting other terms to one side of the equation. This is already done for us. If possible, you want to factor. So if possible, once that's done, factor. Okay, so if you don't remember how to factor, that's something you got to go back over and review. But factoring, the first thing that you look at is there anything in common with all the terms? So if I looked at x squared plus 4x, is there anything in common with both of those terms that I can pull out? And notice that both of them have at least one x, and so we can pull out a single x there. So if we pull a single x out of the x squared term, you'd be left with 1x plus, and if we pulled out an x from the 4x term, we'd be just left with 4. This is equal to 0. Okay, so if possible, factored, and it was possible, so we factored. And then we can set each factor equal to 0 and solve. So I have a factor of x, so I'm looking at this when is x equal to 0? Well, basically when x is 0. And when is the factor of x plus 4 equal to 0? So we have to do a little bit of work there. We need to get x by itself. We can do that by subtracting 4 on both sides. And so if we subtract 4 on both sides, we get x is negative 4. So we have two solutions that work for this equation. And so later on in this course, we're going to notice that the degree of our polynomial will tell us how many solutions that we'll have when we solve it. This is also going to tell us when we're graphing equations, if this had been y equals x squared plus 4x, these solutions, when y is 0, are where we're going to cross our x-axis. And we're going to find many tools later on in this course on how to find those values if this isn't a quadratic equation. So let's say you had x all times x plus 3. That quantity is equal to 10. Okay, so we want to simplify the left-hand side, and we would do that by distributing our x. Common mistake would have students would set x equal to 10 and x plus 3 equal to 10. We can't do that. We can only set the factors equal to 0 if that other side had been equal to 0. So we will need to first distribute the x. And so doing that, we get x squared plus 3x equals 10. So I know this is a quadratic equation, which flags to me that I need to set this equal to 0. Easiest way to set that equal to 0 is to move over the 10. And so undo the 10 on the right-hand side, we would subtract 10 on both sides. So we have x squared plus 3x minus 10 equals 0. Okay, so I'm going to try to factor this. First thing you do is see if there's a greatest common factor amongst all the terms. And there's not, because this term negative 10 doesn't have an x to it. Then you look at an approach how to factor it. So the coefficient in front of the x squared is 1, which makes life so much easier. So you think to yourself, is there any two numbers that multiply to give you your constant of negative 10, but when you sum them together would add to give you 3? And there are two numbers that multiply to give you negative 10 and add to give you 3. So I know some of you guys use like this X to do things. I tend to just show myself. Negative 10 is the number I'm looking to multiply, and I put a plus over the number I'm trying to figure out. So the two numbers that multiply to give me negative 10 and add to give me 3. Well, 5 times 2 is 10. So I know one has to be positive, one has to be negative, and the larger one has to be positive. So 5 and negative 2. Multiply to negative 10 and add to positive 3. So we can factor this as x plus 5 times the factor of x minus 2. Okay, so that one side is completely factored, and it's factored set equal to 0. So we can use the rule, two things multiply to give you 0, then it must equal 0. So we have x plus 5 equals 0, or x minus 2 equals 0. So get x by itself. For x plus 5, you would subtract 5 on both sides, so we get x is negative 5. Add 2 to both sides. For the other equation, we get x equals 2. Okay, so there's two solutions that if we went back and we'll plug those values in for x, would make that a true statement. Okay, so sometimes the equations when we're starting are not quadratic, but when we manipulate it to get our variable by itself, they end up turning into quadratic equations. So similar to what we were just doing with linear equations. So for instance, let's say you had 4 times the quantity x minus 2. And that is all over x minus 3. And then we have plus 4 all over x. Sorry, not 4. It's 3 all over x is equal to negative 3. And that is all over x times x minus 3. Okay, so we got to be careful because we have variables that are in our denominator and we're solving, and so we don't want any of our values or answers that we get back to make the denominator equal 0. So if it helps, then at this point, before we even go through and solve, put a note to ourselves that x cannot be. So you're looking at when is x minus 3 equal to 0? That's when x is 3. And you're looking at when x is 0, well, that's when x is 0. So if we get 3 or 0 back as an answer or solution, then we're going to exclude it. We got equation, and we're trying to clear our fractions. And so we want to multiply each grouping by our LCD. And so if looking at this, the LCD is the quantity x minus 3 and x. So we can kind of save some time in here if we just kind of squeeze into our equation. We're going to multiply every single grouping by x minus 3 times x. So I'm multiplying that first grouping on the left-hand side by that, over my plus. Okay, so multiplying that on each side of our equation and distributing it to each grouping on the one side. So things start to cancel because you have an x minus 3 in common for that first grouping. And so we're left with this 4x outside of the parentheses. We want to distribute it to each piece. So x times 4, I would say 4x. 4x times x is 4x squared. 4x times negative 2, so that's minus 8x. So for the second piece, we have x in common in the numerator and denominator. And so we're left with the 3 times that quantity, x minus 3. So we need to use the distributive property. So 3 times x, so plus 3x. 3 times negative 3, so minus 9, is equal to, and here, x's cancel, x minus 3's cancel. And so all we're left with is that numerator that was negative 3. So it's quadratic. We're going to simplify the one side and get everything to one side so it's set equal to 0. So notice you have a negative 8x plus a 3x. We can combine those. So bringing down the 4x squared, negative 8x plus 3x is minus 5x. And then let's add 3 to both sides of the equation. So negative 9 plus 3, which gives us back negative 6, equals 0. Okay, so at this point, we can either try to factor it. The factoring is not as easy for this because the coefficient, the number in front of the x squared, is not 1. So that makes the case a little harder. I tend to use the AC method where it always works. Some people use trial and error. So I'm going to use that AC method. So basically that's where you take the coefficient in front of the x squared, which is 4, and we multiply it by the constant, the c, which is negative 6. So 4 times negative 6 is negative 24. So we're looking for something that multiplies to give me AC, negative 24, but adds to give us negative 6. So start going through multiples of 24. Well, 3 and 8, that doesn't work, right? I would add to 5. 4 and 6, that's not going to work. 2 and 12 doesn't seem like it works. Okay, so if that doesn't work, that's where we need to use our quadratic formula, which I'm surprised. So if you can't factor, use the quadratic formula, or sometimes you can factor, but they are huge numbers and you don't want to go through it. So let me just kind of remind you what that quadratic formula is. So basically, if you have a quadratic, which is in the form ax squared plus bx plus c equals 0, which we do, then x is equal to negative b plus or minus the square root. All under the square root is b squared minus 4ac all over 2a. And so you just need to go into your quadratic equation and identify what your a value is, what your b value is, and what your c value is. So my a value for this quadratic equation is 4. My b value for this quadratic equation is negative 5. And my c value for this quadratic equation, carry the sign, is negative 6. So all we're doing is plugging those values in wherever you see those coefficient or variables in here. So we have negative b, so negative of -6 plus or minus the square root of -6 squared minus 4 times a times c all over 2. Okay, so plug in -6 wherever you saw b. Plug in 4 wherever you see a, and -6 wherever you see, oops, sorry. That should have been -5. Trying to be color coordinated, sorry. Okay, so simplify, order of operations. Under a radical is treated like a parentheses. Exponents come first before multiplication. So outside, negative of negative, that's positive. So we get x is equal to +5 plus or minus the square root. This -5 is in parentheses, so you carry it when you square it. So that's +25. Minus 4 times 4, that's -16. -16 times 6 is 96. So that's going to be a +96 all over 2 times 4, which is 8. So addition comes next underneath the radical. So we have 5 plus or minus x equals 25 plus 96. It's 121. I just didn't see the numbers. All over 8. So the square root of 121 is 11. So x is equal to 5 plus or minus 11 all over 8. So 5 plus 11 is 16. That's 16 over 8, which is 2. Or we have 5 minus 11, which is -6. -6 over 8. And so I notice that reduces to negative. 2 goes into both of those, 3/4.
I have a question.
Yeah.
So before you did the quadratic equation, when you were factoring and you
Yep.
did the AC method,
Yep.
are we, so we're multiplying 4 times 6 to, and then adding to get, is it -6 or -5?
There, that was my problem. You found why I couldn't factor it. I wrote down -6 there, but you're right. I needed to add what was the middle term, -5.
Okay.
Thank you for seeing that. I was going to go back up and look at it once I figured it out. That should have been -5 from this value. It's always adding to BB. So that kind of want to bring that those solutions. Actually, I need to make sure those weren't the values that I said x could not be at the original. And if we go back up to the original, x couldn't be 3 or 0. So x equals 2 and -3/4 should be the answers as long as I didn't make any little errors in here. So part of this course, we're going to look at, if we're given the solutions, could we find the equation or what that would have been a solution to? And so we could actually figure out what those factors form would have been above. So notice here, we are given like x equals 2 was a solution, and we're given that x equals -3/4 is a solution. Let's go backwards. Find the polynomial. or a polynomial, because there's an infinite of them, and we can talk about that later. With these solutions. Well, basically, because we know x equals 2 is a solution, if we get that set equal to 0, so if we subtracted 2 on both sides, we would say that x minus 2 equals 0 has to be a factor. And then if I, for the other piece, x equals -3/4, let's just make it cleaner so that it's not written as a fraction here. Let's first clear our fraction by multiplying both sides by our denominator, 4. So we could say then 4x is equal to -3. Let's get that so it's set equal to 0. We could add 3 to both sides. So 4x plus 3 equals 0. So these would be factors of our polynomial that gave us a solution. And so we know then x minus 2 times 4x minus 3 equals 0. And so if we distributed this out, then we would see we're going to get back what we had up here that I was trying to factor earlier. So distributing x times 4x, we get 4x squared. Negative x times -3, so that's -3x. I'm going to jump. -2 times, oops, something's wrong again. It's okay, I know it's wrong because I didn't write it down right. Should have been 4x plus 3. Okay, let's talk this through again. X times 4x is 4x squared. X times positive 3x is positive 3x. -2 times 4x is -8x. And -2 times positive 3 is -6. Combine my middle terms, which are like, bring down my 4x squared. 3x minus 8x is -5x. Minus 6 equals 0. And so we just found a polynomial, one of them, that has solutions of x equals 2 and -3/4. Which, way up here, notice 4x squared minus 5x minus 6. 4x squared minus 5x minus 6 is what we got down here. Okay, so sometimes quadratic equations, usually not the fastest, but sometimes if you don't see those factors, or if you made a mistake like I did, and I just jumped to the quadratic equation, I was able to solve it. But sometimes those are not the easiest way to do things. If they're set up a certain way, then we can use what is called the square root method. And so if you had something, let's say, x squared equals 36. If you have a perfect square equals a number. It has to be a number, no term with a variable over here. Then we can use the square root method. So if you have some quantity, it doesn't matter, let's call it capital X squared equals a. So the square root method, we could get rid of the square by taking the square root of both sides. So if I take the square root of x squared, I get x is equal to, I have to put plus or minus in front of at least one of the sides. I usually do it with a number. Plus or minus the square root of A. Because if we square a negative, if I squared the negative square root of A, that would give me back positive A. So I notice I can use the square root method here. I could take the square root of both sides. So if I took the square root of x squared, the square root and the x squared cancel, and I'm just left with x is equal to plus or minus square root of 36. So the number you would square to get 36 is 6. Let's say I didn't see that though. We can always go back and do, a lot of times different methods work. So we could set that equal to 0. If I set this equal to 0 and subtract 36 on both sides, I get x squared minus 36 equals 0. This is factorable. Two terms, I would notice that it's a difference of squares. So this is x minus 6 times the factor x plus 6 equals 0. So if we set each factor equal to 0, x minus 6 is 0 and x is positive 6. And x plus 6 is 0 and x is negative 6. So they both work. It's just that square root method was a lot faster. And it could be done in that case. Let's say you had x plus 2. Quantity squared equals 1. Okay, so multiples, I can do this. I could distribute out x plus 2 times x plus 2, and then get the set equal to 0, and then try to factor it. Or because this is a perfect square on the one side, doesn't matter there's parentheses there, it's a perfect square, it's equal to a number, we can use that square root method. And so we could go ahead and take the square root of both sides. So the square root's going to cancel the square on the x plus 2 quantity square. So we're left with x plus 2 is equal to the square root of 1 is 1. So we get plus or minus 1. So technically we have two separate equations here. We have x plus 2 equal to 1, and we have x plus 2 equal to negative 1. So if I subtract 2 on both sides for the first equation, I get x is equal to negative 1. If I subtract 2 on the second equation, well, negative 1 minus 2 is negative 3. So there's two solutions that would work, negative 1 and negative 3. I'm hoping this is all stuff that is coming back to you really fast. Again, if you don't remember how to factor, you probably should watch a couple of videos on factoring and practice today, because if you don't know how to factor, you're really going to struggle in this course. And any course really that you go on in mathematics afterwards. Okay. So let's say it's not a perfect square, but we can manipulate things to be perfect squares. So we're going to complete the square on this. So our goal is to make the one side a perfect square. So we can use the square root method. So completing the square is a method that you're going to use over and over in math. It's something that we're trying to manipulate sometimes equations to look at like a certain form. And in order to do that, we need a perfect squares. So putting a circle, equation of a circle in a form that we know where the center and the radius is, we need to know how to complete the square. We're going to look at ellipses and hyperbolas, and we're going to need to be able to complete the square. So to complete the square, the condition has to hold that this coefficient, this number, that's another way to say the number, in front of the x squared has to be 1. Okay, so this a value, that's what we usually called it, and the ax squared plus bx plus c. So if a is not 1, there's multiple ways that you can make that 1. Sometimes you can divide all the terms by that number, and sometimes it's helpful to factor that number out of the variable terms. But I chose one that a was 1 so that would make our life a lot easier. So our goal is to make this look like a perfect square. We are going to have to add something to this side of the equation to make this a perfect square. But if we do something to one side of the equation, we got to do it to the other side. So that means we're going to have to add something to the other side. Okay, well, what does it mean to be a perfect square? If you kind of think about it, kind of a side note over here, let's just say x plus a quantity squared. If we looked at that, that's basically saying what's inside the parentheses is multiplied by itself twice, definition of what a square is. And we would distribute this out. So this is actually, if you FOILed this out, you would get x squared and combine like terms, you would get x squared plus 2ax plus a squared. Basically, we're looking for the same number you could multiply by itself if you added it to yourself. So can you think of the same number you can add to get -3? Or another way to think of it is, to find a, if this is -6, a would have to be so divide it by 2, a would have to be -3. So that number that you multiply, -3 times -3, is 9. So the number that we have to add to both sides of the equation to make that a perfect square is 9. Okay, so we just manipulated it so that we could write this one side of the equation as something in parentheses squared. So again, the same number that multiplies to give us 9 and adds to give us -6 was -3. So we can rewrite this as x minus 3 quantity squared equals 13 plus 9, which is 22. So from this point, we now have a perfect square equals a number. And so we can use our square root method. So we take the square root of the one side is equal to plus or minus the square root of the other side. So x minus 3 quantity squared, that square root of that gives me x minus 3 is equal to, unfortunately, there's no whole number I can square to give me back 22. There's no factor of 22 that's a perfect square, so that's as simplified as possible. And I can't pull anything out of that radical. So I want to get x by itself. I know I can't add my 3 to plus or minus root 22 because they're not like terms. And so when I add 3 to the other side, I'm just going to leave it as 3 plus or minus root 22. So there's two separate solutions, 3 plus root 22 and 3 minus root 22. I know I'm rushing, guys. Okay, let's look at one more, completing the square. You don't have to use this method. You can use the method of your choice. I'm not going to tell you what method to use. Basically, what we're going through right now is like a whole chapter in intermediate algebra, and we're doing it in one section. So we're flying. Let's say you had 2x squared minus 3x minus 1 equals 0. So we're going to complete the square to solve. Okay, so in order to complete the square, my coefficient of a has to equal 1. So there's a couple ways I can make that equal 1. In this case, if I just divide everything through by that number, in this case, which is 2, so I'm doing something on one side of the equation, I do it on the other, we can write an equivalent equation. So those 2's cancel, and we're left with x squared minus 3/2 x minus 1/2 equals 0 over a number is 0. So notice that first time our variables were all by itself and that constant was on the other side. And so it's actually easier if we get that constant to the other side. So we can add 1/2 to both sides of our equation. So doing that, we get x squared minus 3/2 x. I'm going to add something here. I'm going to leave a space and come back, is equal to 0 plus 1/2 is 1/2. But if I add something on the left, I have to also add it on the right-hand side of the equation. Okay, so I'm looking for the same number that I could add together to get back negative 3/2. This is not the easier case, but I'm looking for the same number that would add together. So the same number, let's call it, I don't know. I'm going to use a different variable. I don't know. Let's use y. So I'm looking for y, same number y, that I can add together to get back negative 3/2. So I'm looking at y plus y. I'm looking at when is 2y equal to negative 3/2. So if I divide both sides by 2 to get y by itself, if your one side is a fraction, instead of dividing, it's easier to multiply by the reciprocal. Multiplying by the reciprocal would give you 1. So I'm looking at y is equal to, well, negative 3/2 times 1/2 is negative 3/4. Okay, so the same number I would add to get negative 3/2 is negative 3/4. But this value here, I'm sorry, here is that number you have to multiply by itself. So negative 3/4 plus negative 3/4 is negative 3/2, but negative 3/4 times negative 3/4 is positive 9/16. 9/16. So we just manipulated this one side to be a perfect square. The same number you add to get -3/2 and multiply to give you 9/16 was -3/4. So it's x minus 3/4. Quantity squared equals, okay, in order to add fractions, recall you have to have a common denominator. 1/2 and 9/16 do not have common denominators. So I notice I can get a common denominator really quick by multiplying by 1. That fancy one is 8/8. So this is an 8/16 plus a 9/16. 8/16 plus 9/16 is 7/16. So we just manipulated it so we could use the square root method. So we have x minus 3/4 quantity squared. Square root of that is equal to plus or minus the square root of 17/16. So square and the square root cancel out. We have x minus 3/4 is equal to plus or minus. So recall the square root of a fraction is the square root of the numerator over the square root of the denominator. So square root of 17 all over the square root of 16, which I'm going to simplify, I know is 4. I need x by itself, so I have to add 3/4 to both sides. I get x is equal to 3/4 plus or minus square root of 17 all over 4. Those have a common denominator already, so the solution is going to be x equals 3 plus root 17 all over 4 and 3 minus root 17 all over 4.
I had a question.
Yeah.
I was just wondering what section this was from.
This is 1.2.
Okay.
Pause. Okay, so we're gonna have you guys try one. So if you had, let's say, and you can use whatever method you want to use. You have x all divided by x minus 2. And then you have plus 2 all over x plus 1 is equal to 7x plus 1. And that is all over x squared minus x minus 2. So directions say find the real solution, if any, of each equation. Use any method. Okay, so I'm going to give you guys, actually, I'm going to put you guys in groups. So let me, I'm going to pause the recording. Okay, so the students went into a group, breakout sessions, and worked on this together. And the solution was 5 and -1 is what people had come back with. And I was wondering if anybody else got anything different. And you guys are partly right and partly wrong. Does anyone know why you're wrong? As my computer's jumping around. Aha, someone said
Because
it.
x can't be 1 or
Yeah,
-1.
Right, so looking at that equation, go back to it. Right, so and this is going to happen sometimes. I'm trying to figure out a good program where I can do notes on. But sometimes my screen kind of jumps around. So I apologize. But if you notice that denominator, you can't have any values which set the denominator equals 0. And so x cannot be positive 2 and x cannot be negative 1. And so when you said x was 5 or negative 1, you're right. It's called an extraneous solution when you get an answer that actually is not part of the solution. This one problem, you had to do one little step further. In this case here, if possible, when you have your denominators, you want to make sure your denominators, when you're looking for your LCD, is factored completely. And you would have noticed that this was factored as x minus 2x plus 1, which is nice because those are the factors that we have over here, and which is our least common denominator. Okay, so I'm not going to go through that problem, but if you have problems with it and you need help with it, and you weren't able to finish it when you were in your breakout room, then ask a tutor about it, go and talk to them about it and get some help. So we are almost getting close to the end of class time, and we're pretty much done with 1.2. My goal was to get through 4 sections today, guys, and I got through 2. Tomorrow is, the next section is on complex numbers, so and imaginary numbers. So that should be pretty quick and fast. And then what else do we have? Radical equations, so equations that have radicals in them, which kind of opposite. We were taking the square root of both sides to clear the square. This time we're going to raise both sides to a power to get rid of the radicals. And then we get into inequalities. So hopefully I can get through this entire chapter tomorrow. So right now you should be able to get to chapter 1.1 and 1.2 in your homework. Let me pause the recording and then I'm going to take roll real quick.